In this lecture, we are going to write a program to initialize the GPIO peripheral of our microcontroller, that is STM32F407 microcontroller, right? So, various devices or a number of devices and peripherals can be operated using the GPIO pins, right? Such as LEDs, LCD, matrix keyboard, switches, stepper motor, DC motor, relay. So all these things can be operated using the GPIO. So here we are going to write the function for initializing the GPIO, right? So I will initialize the GPIO for a particular peripheral in this lecture. That is, we will use LED for demonstrating the purpose of the GPIO, right? So the LEDs that we are going to use will be from our ASK25 board. That is our all-in-one general purpose board. So on your screen you can see that this is our ASK25 board, and there are several peripherals populated here such as LCD, these are the 8 LEDs, then a relay, driver IC for stepper motor, DC motor, then 7 segment LEDs, matrix keyboard, switches, and analog input for the ADC also. So these many things are available on this board. So from here we are going to use this 8 LEDs, right? You can see here there are 8 LEDs, and the pins of this 8 LEDs are being brought out on this connector, this lower one. There are two connectors, two 20 pin box type connectors available. So the pins of all these peripherals are divided into these two connectors. So the name of this connector is PL8. Okay, so now I will show you the user manual of this ASK25 board. So on your screen you can see that I have opened the user manual for ASK25 board, and this is the diagram for our PL8 connector where our LEDs are mounted. So you can see that 20 pins are mentioned and the functionality of each pin is mentioned. So there are 8 LEDs, right? So from LED 1 to LED 8. So these 8 LEDs are connected on pin number 10 to pin number 17 of this connector, right? And on this same pins, a single 7 segment LED is also connected. So whenever we will operate our LEDs, this 7 segment LED will also glow. Right, so pin number 10 to 17 are connected over here. Okay, now again on your screen you can see that this is our microcontroller board. So this is basically our microcontroller board is mounted on the top of this baseboard. So this baseboard is from Edutech Learning Solutions. Okay, and this baseboard is made with the sole purpose of getting the ports of each and every peripheral that is present on this microcontroller. So if you see carefully, then this box type connector you can see here. So there are several GPIO pins that are brought out on this box type connector. This is also a 20 pin connector similar to that was present on our ASK25 board here. So let us see that which GPIO pins we have brought on this 20 pin box type connector. So now I will open the user manual of our baseboard, right? So this is the 20 pin GPIO connector and it is given a name PL17. Okay, so in this 20 pin connector you can see that pin number 18, 19 and 20 are 5 volt, 3 volt and ground, right? So there are basically 17 pins available for us. So you can see that from pin number 1 to pin number 4 we have put port E pin number 4 to 7, right? And from pin number 5 to pin number 8 we have put port B pin number 0, 1 and 4 and 5, right? Pin number 9 is not connected, it is floating. Pin number 10 to pin number 17 is port E pin number 8 to 15. So 8 pins are of port E are from pin number 10 to pin number 17, and our LED on our ASK25 board was also available from pin number 10 to pin number 17, correct? So now what we are going to do is we are going to use port E basically, and we are going to use the last 8 bits of our port E, that is pin number 8 to pin number 15. We won't use pin number 0 to 7 for glowing the LEDs, right? Okay, so now this was all about the interfacing between the ESK25 board and our microcontroller. So now let us get started with the initialization function. So now I will open the Eclipse IDE. So just this is the template that we are going to use. So just copy and make a copy of this template in this uh, project explorer itself and give it a name, GPIO. Okay, so project of GPIO is created now, and you can go here in the drivers in the BSP. Now we have to write the drivers for GPIO, right? First of all, so just right click on this include folder and create a header file and give it a name, bsp underscore gpio dot h, and similarly go to the source file, and there also you can make a source file by the name bsp underscore gpio dot c. Okay, so let us go to our header file first of all. So first, what will we do? So first of all, we will include the necessary library functions, right, or the header files. So I will include, first of all, I will include stm32f4 underscore global dot h. So in case we want to use some core functions of our microcontroller or some conditional macros, such as the conditions for true or false, on or off, right? So these kind of macros and functions can be used from this stm32f4 global file. Okay, you can take a look, it is present in our template by default. Then the next library I'm going to add is stm32f4xx underscore hall.h. So using this hall.h library in our header file gives us access to all the hall libraries or hall functions that are present in our template, right? So now we have to make our function for initializing, right? So first of all, let us declare it here. So the name of my function will be void ask25 underscore led underscore init. So this is the name I am giving for my initializing function, because we are using the LEDs from the ASK25 module of EduTech. Hence I will give it the name like this, right? And I won't pass any parameter. Okay, so this is the function that is required. Okay, so let us save this file and let us define it in our source file. So just go here and add necessary header files. So here only one header file needs to be included, that is our bsp underscore gpio.h, right? And in here we are going to use the function void then ask25 underscore led underscore init. Okay, so let us get started. So first of all, we need to use the hall drivers. So just go to hall drivers folder and in that include and open the gpio.h file. So in the gpio.h file, you will find a structure by the name gpi underscore init type def. So this structure basically configures all the parameters that are required for operating GPIO on our microcontroller. So I will just copy this structure and I will paste it here, and I will give it a name GPIO underscore init struct. Okay, and we will configure all these parameters that such as pin, mode, pull, speed, alternate of this structure one by one, and then we will pass this whole structure into our initialization function that is provided by hall. Okay, so first of all, before that we need to initialize our port clock. Now as you know that we are going to use port E for interfacing, right? So we need to initialize clock for port E. So for that you need to go to the hall drivers in the legacy and open this legacy.h file. So if you scroll down below, then you will find that GPIO clock for each and every port of our microcontroller. So we want to enable the clock for port E, right? So just select this GPIO port E clock enable. So just copy it and paste it over here and use it like this. So your GPIO clock is enabled now. Then after that, what will you do? Then let us configure one parameters of the structure one by one. Okay, so the first parameter we will set as pin. So which are the pins that we need to configure as GPIO? First of all, we need to select that. Now we want to select pin number 10 to pin number 17, right? 8 pins of port E. So, and all of them are LEDs. So rather than using or writing the definition for each pin, let us create macros for them. Okay, or even better, macros take a lot of space, and so we can make enumerators for that. Okay, so for creating enumerators, let us go to our bsp underscore gpio.h file. So here I will create one enumerator, that is type def space enum, right? And for LED1 I will give a name. It is LED from ESK25, so I'll give it a name ALED1 equals to 0 cross 0 1. So let me tell you how the structure here works for LEDs on our ASK25 board. So our ASK25 has 8 LEDs, right? That is LED 1 to all over LED 8, and you can consider them as 8 bits of your port. So basically your GPIO port E, that is port E, is of 16 bit. Okay, and these LEDs can be totally configured into 8 bits. So what we are going to do is we will name them, that suppose this LED the 8 is the last bit of our register, so we will give it a name 0 cross 0 1, right? And our pin number, this is pin number 15 and this is pin number 0, and our LEDs are connected from pin number 8. So pin number 8 to pin number 15 are our LEDs, but basically if I write 0 cross 0 1, then it will set pin number 0. Okay, so every time we define a pin or give a value to a pin, we will left shift it by 8, right? So when we left shift our pin by 8, then it will go to its actual location, that is between pin number 15 to 8. Okay, so let us give it the value. So for first pin it will be 0 cross 0 1. Okay, so our next LED is ALED2, right, and its value is 0 cross 0 2. Okay, so this is in hex form. I am giving the values, right? So I am giving the value to the each bit of our microcontroller all over from 0 to 8, right? 0 to 7, sorry. So similarly for LED3 it will be 0 cross 0 4. For LED4 it will be 0 cross 0 8, and for LED5 it will be 0 cross 1 0. For LED6 it will be 0 cross 2 0. For LED7 it will be 0 cross 4 0, and for finally LED8 it will be 0 cross 80, right? And we will make one more enumerator for LED all. That is, if we want to glow all the LEDs, then I will give it a value 0 cross FF. That is, all the LEDs are selected now. Correct. So this is our enumerator, and let us give a name to our enumerator. Like I will give it a name ALED underscore type def. Correct. So our enumerator is defined now. Now just save your file and go to your source file. Okay, so in the source file now, in the pins, now what will I put here? I will put ALED all, right? That is, I am selecting all of my GPIO pins and I am left shifting them by 8, right? Because I told you that when while we are defining it here in our header file, that is 0 cross 0 1 0 2, so it will set all the 8 pins between pin number 0 to pin number 7. But as you know, all our pins of LEDs are connected on pin number 10 to pin number 17, right? So we have to shift them 8 times left so that they can reach to their actual position. Okay, so here in the first case, if I am for LED1, I am giving it a value 0 cross 0 1. That is the first bit of my port E. But for actual LED1 is present on pin number 8. Okay, so I will shift my data from my 0th location to the 8th location. So how will I do that? I will do that by shifting 1, that is the data on bit number 0 to 8 times, so that it will go to bit number 7, that is the 8th bit. Okay, so in this way we are going to configure all our pins, right? So the first parameter was the pin. Now the pin is defined. So now let us set the next parameter of our structure, that is init struct, and the next parameter we will set it as mode. So for mode, all these parameters, their options are available in the hall header file for GPIO. So if you open this hall gpio.h, then you can see that there are several macros they have provided. So these macros are basically the options of each and every parameter. Suppose they asked for pin over here, right? So it is for our convenience we made this enumerator for our LEDs. But if you didn't want to, then you can configure it using these GPIO pins also. Look, they have provided the macros for all the 15 GPIO pins, okay, and the address for them also. So you can set your GPIO pins from here. Now we want to set our GPIO mode, right? So for mode, also they have provided macros. So these many macros are provided for mode. That is for push pull or open drain or whatever we want to use. So we are going to use our GPIO mode as output push pull. So I will just copy it and I'll paste it over here. Correct. Then the third parameter is GPIO underscore init struct dot pull. So the third parameter we are setting is pull. So for pull also they have provided macros. So let us take a look at that. So there are three options. That is, one is no pull, the second is pull up activation, and the third is pull down activation. So we will configure our pins at no pull. Okay, and I will paste it here. And then the next one is GPIO dot init struct dot, then sorry, it is underscore here. So GPIO underscore init struct, then the next parameter is the speed. So in our microcontroller they have given a provision for us to set the speed of each GPIO pin. Okay, so for that also they have given macros. So they have given four options for the speed, that is low, medium, fast and high, and they all go according to the maximum frequency. So the high has the maximum frequency, fast has a little bit less, medium has even more less, and low the least. Okay, so we will set our pin at fast. Okay, okay. And there is one more parameter inside the structure, that is alternate. Okay, so if you take a look at this structure again, then you can see that there is another parameter called alternate. So there is no need of setting the alternate as of now, because the main purpose of this pin is for it is to be used as GPIO, right? But each pin has multiple functions. That one pin can be, for example, used as ADC also, UART also, right? So all these functions are multiplexed on one pin. So if you want to use any other peripheral other than GPIO, then you have to set this parameter alternate. Okay, so we don't need to set this because we are using this as GPIO only. Now all the parameters of the structures are configured. Now we need to pass this structure into a function which initializes the GPIO. So just go into the hall drivers, and in here there is a function already available that is being provided by hall, that is hall underscore GPIO underscore init, and it takes two arguments. So the first argument that it takes is the port name, right? So which port we want to initialize, and then the second argument is the structure that we have just configured, that is all the rest of the parameters, right? So I will copy this whole function from here, and I will copy it here. So the first we need to give the port name. So they must have defined the port name somewhere, right? So they have defined in their main header file, that is the memory specific header file. So for that you need to go to the CMSys, then in the device ST, and if you go to this include, then you will find STM32F407XX.h file, right? So if you open this and if you scroll down, then you can find the GPIO. So here the address for GPIO port is E is available over here. So we will just copy this macro and we will replace it in the first argument. Okay, and the second argument is our structure, that is this one. So I will copy it, and as they're asking for a pointer, so I'll have to dereference and give it. So now the structure is passed. So as soon as this function is executed, our GPIO pins of port E will be initialized, and when they will be initialized they will be set as high by default, and in our case we are using LEDs, right? So by default our LEDs will glow as soon as this function is initialized. So now we have to turn off these LEDs, that is we have to get this pins to logic low. So for that go to your gpio.h file and just use this function hall underscore gpio underscore write pin, that is you can write high or low on any pin of any port using this function. So just copy this and paste it over here, and similarly just give the port name. So the port we are using is GPIO port E. We have to give the pins. So our pins that we are configuring is this, that is LED all, and we have to shift it by 8, right? So I will just select that and paste it over here, and then we have to set the pin state. So what is the pin state? So for pin state it is defined in the hall gpr.h file only. So if you scroll down, then you can see in pin state it is a enumerator which contains two elements, that is reset and set, that is 0 for reset and 1 for set. Okay, so we will set in our case. Now we want to make all these lines low, but we are setting it. So why? That is because the LEDs that are present on our ASK25 board, they are active low. Okay, so if we send them 0, then they will glow, or if we send them 1, then they will be reset or be turned off. So For turning them off, we have to send GPIO pin set, that is 1. Okay, so in the GPIO pin state I will put like this. Okay, so our LED is now initialized, correct? So just save it, and your function for initializing the GPIO is ready now.